Hello. Okay. Good morning. Okay. Yeah. Okay. Okay. So yesterday we were up to um chemistry chapter 2. Yeah, okay. So we finished all the notes. Yeah, we finished all of the notes. So today we will take a look at the workbook. Okay. Yeah, so unit 2 workbook. Okay. Yeah, so we can go through some questions together. Okay, so first question. Distinguish between the terms compound and mixture using specific examples. Yeah, okay. So we can see here, this is the difference between compound and mixture. Yeah, so compound, mixture. So compound, we have, okay, so different atoms joined together with chemical bonding. Yeah, different elements joined together with chemical bonding. Okay, but mixture, we have different things mixed together, but no chemical bonding. No chemical bonding. So that's the difference between compound and mixture. Okay. So our answer will be something like this. Okay. Okay. The elements in a compound, example, iron sulfide. Okay. So iron sulfide, FeS. Okay. Iron sulfide cannot be separated by physical means. Okay. So they have a chemical bonding. We cannot simply separate it. Okay. Physical means like filtration, okay, something like that. Cannot. Okay, or with a magnet, cannot. So this is a chemical bonding. But mixture, okay, mixture of iron fillings and sulfur powder. This is still iron. This is still sulfur. Okay, this is compound. Okay, but this is mixture. Can be separated using a magnet. Okay, so if this is a mixture, it can be separated using a magnet, which is a physical method, but compound cannot be separated by physical method. Okay. Okay, next, look at the list of substance. Okay, list of substance. Which of these substances are compounds? Okay, so which one is a compound? Okay, yeah, let's take a look. Our answer will be, okay, carbon monoxide. Okay, so carbon monoxide is carbon triple bond to oxygen. Yeah, okay. So this is a compound because there is a chemical bonding. Sulfuric acid, okay, H2SO4. So this is a chemical compound with a formula. Methane, CH4, okay, chemical compound, okay, with a fixed proportion. Sodium hydroxide, NaOH. Yeah, okay. Sodium hydroxide is also having a chemical formula. Limestone, okay. So limestone is calcium carbonate, CaCO3. So these are all compounds. Okay. Next, mixtures. Okay. So which one will be mixtures? Okay. Stainless steel. Okay. So let me just copy the example. Yes. Okay. So as mentioned before, okay. Okay, so steel will be iron plus carbon. So stainless steel will be iron plus a little bit of maybe chromium, nickel, something like that. Other metals, okay, mix a little bit. So makes it stronger and more resistance to rusting. Okay, lemonade is water, okay, with the lemon pieces. Okay, so this will be a mixture also. Okay, so cement will be like the sand, okay, plus the clay, something like that. Okay, so all mixed together, giving us the cement. Okay, So how about beer? Okay, so beer we have again water, okay, and then we have alcohol in it, something like that, and then maybe some um sometimes the beer we have a taste of fruit, okay, so taste of flower, something like that. So all of these molecules mix together, so this is also a mixture. Okay, brass, okay, yesterday we mentioned about that. Okay. uh oh no, we don't have. Okay, so what is brass? Okay, brass is copper. Okay, so this one bronze is copper plus tin. So brass is copper, okay, plus zinc. Okay, so these are all alloys. Okay, so alloys are mixture. Yesterday we mentioned. Okay, why we say they are mixture? Because of this. Okay, because we have these atoms, metal atoms, they are mixed together. So this is not a fixed proportion. Yeah, not fixed proportion. So we are saying that they are alloy. So we can add more or less the atoms. Okay, so we can add more or less of them. Okay, next. Okay, so this one we need to pick the odd one out. Okay, so which one is not in the same category? Yeah, which one is not in the same category? Okay, so okay, so based on our understanding, so petrol, okay, so petrol is actually a mixture, okay, so because it's made up of okay carbon compounds, okay, so maybe C2, H6, okay, C4, H10, something like that. So the carbon compounds with different formula. They mix together in the petrol. So this mixture, okay, oil is also a mixture. Okay, so same concept there. So the oil is also a kind of petrol, so it can also mix mixture, okay, of different carbon compound. Yeah, okay. So this is also a mixture. Okay. Water is a compound. Yeah, because it's H2O, only H2O, one type of substance, okay, with chemical bonding, okay, and then fixed ratio. Air is a mixture of different gases, okay, oxygen, nitrogen, um, carbon dioxide, okay, mixture of gases. Brass is also mixture, okay, just now we mentioned it is alloy, okay, made of copper and zinc. Okay, so the odd one out will be the water. So water is the only, no, not A, is the water. Okay, so it's the only compound in here. Okay, water. Explanation, because water is a compound. The rest they are mixture, 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 mixture. Okay, next. Okay, we have lead nitrate. Okay, so lead nitrate, it looks like this. PbNO3, okay, 2 units. So we can see clearly this is a compound with formula. Yeah, okay. Potassium oxide, K2O. Okay, so this is also a compound. Compound. Okay, compound. Chromium. Okay, so chromium, if we look at the periodic table, okay, let me see. The periodic table. Ah, yes. Okay, periodic table. Okay. Ah, okay, not so clear, but if we see here, chromium. Yeah, okay. So if we can find it on the periodic table, means it is element. Yeah, okay. Chromium is element. Hydrochloric acid, HCl. Okay. Yeah, so this chromium, HCl. So again, this is a compound, two element joined together. Okay. Silicon dioxide, SiO2. So this is a compound. Yeah, okay. So all of them have chemical formula, different elements joined together. So the odd one out, it is chromium. Okay. Reason, it is element. Okay, next. Okay. So hydrochloric acid is compound. Fluorine, okay, is F2, like this. Okay. So this is only one type of atom. One type of atom. So if we look at the periodic table, we can find it. Fluorine here. Okay. Yeah. So fluorine is element. Okay. MgO, again, this is a compound with formula. Iron sulfide compound, CO2 compound. So the odd one out, it is F2. Yeah, okay. So it is element. Okay, next. Okay, water, H2O is a molecule. What do you understand by the term molecule? Okay, so molecule, like this. Yeah, okay. So molecule, basically what it is. Okay, we can take a look. It's a group of atoms. Okay, example, water, a group of atoms chemically joined or bonded together. Okay, so actually this fluorine, this is also a molecule. Okay, even if it is element, it is still a molecule. So this is also a molecule. Okay, so which means molecule, we can have two category, which is element and compound. Okay, so example, F2 compound will be water. Okay, so whether they are elements or compound, if they are a group of atoms that have chemical bonding, means they are molecules. Okay, next. Okay, a mixture of zinc metal powder and sulfur. Okay, so we have zinc atom and sulfur atom. Okay, heated strongly in a test tube. Okay, so we put in a test tube. Okay, this zinc and sulfur, and then we will heat it up. Okay, bright red yellow glow spread very quickly throughout the mixture during the reaction. Okay, so we can see some changes. Okay, so we can see some changes, and then we get a white powder. Okay, so this telling us this is a chemical reaction. Okay, this is not a physical reaction, chemical reaction. Okay, so yeah, so basically we have zinc react with sulfur. Okay, that is giving us the zinc sulfide. So this is a chemical reaction. Okay, what are the safety precautions? Okay, so if we are doing this kind of chemical reaction in the lab, what are the chemical reaction? I mean the safety precaution. Okay, yeah, so we need to use eye protection, safety goggles, safety spectacles to protect our eyes. Okay, what is the bright red yellow indicate? Okay, so bright red yellow means we have a chemical reaction and then we produce a new substance. Yeah, okay. So if we just simply mix together the zinc powder and sulfur, it's just a mixture. Okay, but it won't have bright red yellow. So when it has bright red yellow means something new is formed. Okay, chemical name of the white powder. Okay, yes, just now we mentioned zinc sulfide, but they want the name, so we need to write in full zinc sulfide. Okay, next, write a word equation and a balanced chemical equation. Yeah, word equation means we need to give it in full name. Chemical equation we present as a symbol. Okay, okay, word equation just now we mentioned. Okay, so this is word equation. This is chemical. Okay, with the symbol zinc plus sulfur arrow, zinc sulfide. Okay, and then zinc symbol, it is a solid at room temperature. Sulfur, symbol, solid at room temperature, arrow, forming zinc sulfide. Okay. It is this a white powder, so it is also a solid. Okay. So zinc sulfide, okay. Why it is zinc, one sulfur? Why not zinc 2 sulfur 2? Why not like that? Okay. So this one we will learn a little bit later. Okay. The main reason because the zinc, the charge is 2 plus, the sulfur, the charge is 2 negative, the ions. Okay. So to balance the charge, you only need one zinc and one sulfur. Okay. The white solid is a compound. Explain the difference between mixture, zinc and sulfur, and the compound formed by the chemical reaction between them. Okay. So yeah. Okay. So we can do it two ways. Okay. So just the zinc plus sulfur, okay, we just mix together. Okay. So another one is the zinc and sulfur we heat up. Okay, so after we heat up, it actually form the compound zinc sulfur. Okay, zinc sulfide. Okay, so this one will be compound. This one is, okay, mixture. Okay, so this one is just simply mix. No chemical, okay, bonding. Okay. Okay. So zinc and sulfur can be separated by physical means. Yeah. So this one can be separated easily. Okay. For example, using organic solvent to dissolve the sulfur. Okay. So for example, we can put the organic solvent, we can dissolve the sulfur, and then we can filter to collect the zinc. So it can be separated easily. But the compound zinc sulfide, okay, zinc sulfide. So this one is zinc plus sulfur. This one is zinc sulfide. Need chemical means to separate the elements. Okay, so it cannot be separated easily. Okay, next. Okay, the metal copper can be extracted from its ore, copper sulfide, in a two-stage process. Okay, so copper sulfide. Okay, so this is copper sulfide. This is copper. Okay, so the copper sulfide is not really useful. Okay, so although it has copper inside, it's not really useful because it's just like a rock. Okay, so there's not much use. But copper is a metal. Yeah, okay. So it can make into like wires, okay, sheets, something like that. Maybe like frying pan, something like that. Okay. So basically it is a metal. It's very useful. So we want to take this ore, okay, and then we will go through some process to get the copper always. Okay. So copper is the useful one. So the process, okay, copper sulfide react with oxygen at high temperature to form copper oxide and sulfur dioxide gas. Okay, copper sulfide when we react with oxygen, so that will give us copper oxide plus sulfur dioxide. Okay, something like that. Okay. Then okay, the copper oxide is reacted with carbon again at high temperature to form copper metal and carbon dioxide gas. Okay, copper oxide reacted with carbon, so end up with um copper and then carbon dioxide. Okay, something like that. Okay. Yeah, so this one is okay, so this one is not yet balanced. Okay, so this just to present like what is going on. Okay, so later we will practice how to balance this chemical equation. Okay, name the elements mentioned in the passage above. Okay, so all of the elements, so we can see uh okay, name all the elements. Okay, so basically we have copper. Okay, just now we mentioned oxygen. Okay, here, carbon, here. Okay, all the elements. Okay, yeah, copper, oxygen, carbon. Okay, yeah, oxygen here. Okay, next, name the compounds mentioned. Okay, compound. So we can see here, copper sulfide, copper oxide, sulfur dioxide. Okay, and then carbon dioxide. So these are all compounds. Okay. Yep. So this is the difference between elements and compounds. Okay. So this is just one type of atom. Copper, oxygen, carbon. One type of atom. So this one is, okay, combination of different atoms. Copper sulfide, copper oxide, sulfur dioxide, carbon dioxide. Okay, so these are all compounds. Okay, write word equations and balance chemical equations for the reactions described in the passage. Okay, so now let us try again. Okay, first reaction, we take copper sulfide, react with oxygen to form copper oxide and sulfur dioxide. Okay, so now we try to practice balancing the equation. Okay, yeah. Okay, so we try to practice. Okay, so we have copper sulfide plus oxygen. Okay, so oxygen is always O2. Okay, and then copper oxide plus sulfur dioxide. Okay, so again, as I mentioned before, why this is copper 1, sulfur 1? Why this copper 1, oxygen 1? Why not copper 2, sulfur 2, copper 3, oxygen 3? Why? This one we will learn later in later chapter. So at this moment, we just need to know, okay, copper sulfide, okay, and copper oxide. They are 1 to 1, okay. So now, okay, we try to balance it. Okay, left hand side, okay, right hand side. Okay, okay, left hand side, 1 copper, okay, 1 sulfur, okay, 2 oxygen. Yeah, okay. Okay, left hand side, right hand side, 1 copper. Okay, 1 oxygen. Okay, so actually got 3 oxygen. Okay, because here 1, here O2, 3 oxygen. 3 oxygen. Okay, and then 1 sulfur. Okay, like this. Okay, so we already can see some conflict. Okay, here is 2 oxygen. Here is 3 oxygen. Okay, so what we can do, okay, we can make it 2 here. Okay, so if we make it 2, okay, what happened if we make it 2? Okay, so 2O2, so this will be 4 oxygen. Okay, okay, but here it is still conflict. Okay, um so what we can do, we can try an error. So for example, we can make this 2. Okay, so let's say we make this 2. So now will be 2 copper. Okay, and then the oxygen will be 2 oxygen, 2 oxygen. So here will be 4 oxygen. Okay, so it works out. Okay, at this moment. Okay, now we can see this copper is conflict. Here, this is 2 copper. This is 1 copper. So what we need to do, we add 2 here. Okay, so now this is 2 copper. Uh, now the sulfur, it become 2 sulfur. Okay, so now we have a new conflict. Okay, so if we want 2 sulfur, so here it will become 2. Yeah, so here it become 2 sulfur. Okay, but now the oxygen change. 2 times 2, 4 oxygen plus 2. So here will be 6 oxygen. Okay, so now we need to fix this. Okay, so how to fix this? We put this 3. Okay, 3 O2, 3 times 2, 6 oxygen. Okay, so now we check again. 6 oxygen, 2 sulfur, 2 copper. Okay, so now it's done. Okay, so now we have successfully balanced the equation. Okay, so we can check our answer. Yep. Okay, 2 copper sulfide plus 3 oxygen plus produce 2 copper oxide and 2 sulfur dioxide. Okay, so we also need to give the um uh state symbol. So copper sulfide is a solid. Okay, oxygen is gas, copper oxide is also a solid. Okay, sulfur dioxide is a gas. Okay, so why we know all of these state symbol? It comes from experience. Okay, so when you study chemistry for a while, you will have an idea. Okay, what are the state symbol? Okay, next one. Okay, so next reaction after we get the copper oxide, um, okay, we will react with carbon. Okay, so we'll react with carbon. So why this reaction can happen, we will also learn later. Copper oxide react with carbon, turn to copper and carbon dioxide. Okay. Okay, so how we balance this equation? So we have copper oxide plus carbon. Okay, it turns to copper plus carbon dioxide. Okay, so again, okay, left hand side, okay, right hand side, okay. So we have 1 copper, okay, hold on. Okay, 1 copper, 1 oxygen, okay, 1 carbon. Okay, here we have 1 copper, okay. Yeah, so if you have any question, just stop me at any time. Okay, 1 carbon and then 2 oxygen. Okay, so we can see this conflict here, 2 oxygen and 1 oxygen, which means we need to make it 2. Okay, so if we make it 2, so here we have 2 copper and then 2 oxygen. Yeah, okay. So as I mentioned before, we cannot simply change the formula CuO2 like that. Cannot. Okay. So we can only change the number that is in front. Okay. Yeah, so we cannot do that. Okay. So now 2 copper, 2 oxygen, okay, is okay now. But here we have the conflict, okay, 2 copper, 1 copper, so we make this 2. So now we have 2 copper. Okay. Okay, let's check again. 2 copper, 2 copper, 2 oxygen, 2 oxygen, 1 carbon, 1 carbon. Okay, cool. So this is done. So our final equation will be like this. Okay, 2 copper oxide plus 1 carbon turn to 2 copper plus carbon dioxide. Okay, and then copper oxide is solid, carbon is solid, copper metal is solid, and then carbon dioxide is a gas. Okay, next. Okay, so here the table shows the formula for some compound. So we need to complete the table. Okay, so we can see one example here. Okay, so given this formula here, we suppose can list out what are the symbol present. Okay, so we can see there is a lithium, nitrogen, oxygen. Okay, the name, lithium, nitrogen, oxygen. Okay, so how many lithium? 1. How many nitrogen? 1. No number means 1. Okay, O3 means 3 oxygen. Total number of atoms, 3 plus 1 plus 1 equals to 5. Okay. Okay, we can go through one more. Okay, and then maybe you can try. Okay, so maybe you can try by yourself. Okay, so the next one, okay, Ca, okay, is one element. So we CaCO3. So what's our answer? So we have Ca, C, and O. The name Ca is calcium, C, carbon, O, oxygen. Okay. So how many calcium? 1. How many carbon? 1. Oxygen? 3. Okay. So 3 plus 1 total 5 atoms. Okay. So this one Mg3N2. Okay. Maybe you can have a try. You can have a try. So for the symbol, the first one, it will be just Mg, right? Okay. And then N. Okay. So do you know what is the name for Mg? Do you know what is Mg? What is Mg and N? The name of the element. Okay. If not, we can take a look the periodic table. Okay. Yeah. Okay. So let me just open the periodic table. Okay. Wait. Let's see. Okay. Can remember what is Mg and N? Okay. Yes. So this is one of the past exam paper. So we have, okay, given periodic table in the end. Yes. Okay. So if we look at here, okay, Mg is magnesium. Yeah, Mg is magnesium. Okay. And then N, nitrogen. Yeah, okay. So just need to search around for it. Okay. So Mg, magnesium, N is nitrogen. Okay. So you can get it from the periodic table. How many Mg we can see? This is 3. Nitrogen is 2. Okay. So 3, 2. So total again, it is 5. 3 plus 2, 5. Okay. Now here, AgCrO. Okay. So these are 3 elements. Okay. AgCrO. Okay. Ag, we can see here, this is 2. Chromium, 1. Okay. Oxygen, 4. Okay. So again, the name we can get from here. Okay. Ag is silver. Yeah, Ag is silver. Cr, chromium. Yeah, okay. So we can get the name from the periodic table. Okay. Yes. Okay. Silver, chromium, oxygen. Okay. And then number. Okay. 2 silver, chromium is 1, oxygen is 4. Okay. So total 4 plus 2 plus 1, total is 7. Okay. Next. Okay. Balancing equation. Okay. So this one maybe you can have a try. Okay. So you can try and then you just tell me this number. Okay. This 3 number. Okay. Try for question 1. Balancing the equation. Okay. So if you can do it, you just try. If cannot, we will go through together. Okay, have a try for this one, balancing the equation. Okay, try it out.
Mm, 2, 1, 2. Two, 1, 2. Your mic is off. Hello?
Ah, yes, yes, yes. Sorry, I mute myself. Yeah. So 1 and 2, totally correct. Okay, that's great. That's great. Number 3.
1, 2, 1, 2. No, 1, 2, 2, 1.
Okay, your answer is 1, 2, 2, 1. Huh? 1, 2, 2, 1. Okay,
No,
1,
2.
2, 2.
I think the
Ah,
last one is 2.
the last is 2.
Yeah.
Okay,
Is
1, 2, 2, 2. It is different to my answer. Do you want to try again?
Yeah. 1, 3, 2, 2.
Correct. Excellent. Yes. Okay, that's great. That's great. So you totally understand about balancing equation. That's great. That's great. Okay, next. Yeah. So this one is about this topic here. Just now. Yesterday we did this. Okay. So we need to know how to count. Okay, count the number of proton, number of electron, number of neutron. Yeah. So for example here. Okay. Yes. For example, given this information from the periodic table, you can work out how many proton, how many neutron, how many electrons. Yeah. So this is about the next question. Okay. So we need to work out for this one. Lithium, boron, aluminium, nitrogen, calcium. Okay. So what I'll do, I will just copy everything from the periodic table first, and then we can try together. Okay. So let me just highlight everything. Okay. So lithium, um, boron. Okay. And then aluminum. Okay. Hold on. Okay. Aluminum, nitrogen. Okay. Okay. Nitrogen, and then calcium. Okay. 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 Let me just copy this. Okay. And then put here. Okay. Then we can use it for our question. Yeah. Okay. Lithium and calcium. Okay. Yes. And then okay, boron, nitrogen, aluminum. Okay, so these are the information that we need. Okay. So we will try the first one together, and then after that you can also have a try. Lithium. Okay, so if we go to the periodic table, okay, okay, lithium. Okay. So we want to know uh proton, neutron, electron, and then nucleon number. It means just the mass number. Okay, so mass. Okay, so lithium, we are given the mass number, which is 7. Okay, 7. Okay, we also given the number of neutron, which is 3. Okay, so actually without the periodic table, we can also work it out because we know proton plus neutron is equal to the mass number. Okay, so now we already know the mass number is 7. Neutron is 3, so which means this part it is 4. Okay, so proton is 4. And then before any chemical reaction, just the atom, okay, proton equals to electron. So electron is also 4. Okay, so our answer will be proton. Wait. Yes. Okay, so proton should be 4. Okay, so proton should be 4, and then the number of electron, it should be 4. Ah, okay. I see what's the problem. Okay, the number of neutron, actually, it should be 4. Okay, the the question is wrong. Okay, the question is wrong. The number of neutrons should be 4 because if we look at the periodic table, proton number is 3. Yeah, proton number is 3. Okay, so we are given the wrong information here. Okay, so proton is 3, electron is 3. Okay, so neutron is 4, so this is 3 here. Okay, actually the question is wrong. Okay, luckily we check the periodic table. So the proton number will be 3. Okay, and then the number of electron, this is also 3. Yeah, okay. Let's try one more together. Boron, proton number is 5. Okay, we're checking. It's correct. Mass number 11. Okay, we're checking. That is also correct. So now, boron. Okay, proton, neutron, electron, mass number. Okay, mass is 11. Proton is 5. Okay, so neutron will be mass minus proton, which is 6. Okay, so neutron should be 6, and then electron will be the same as proton. So this will be 5. So this will be 6 and then 5. Okay. All right. Okay. So maybe aluminum, nitrogen, and calcium, you can try. Okay. So you can have a try and then tell me about aluminum, the proton number and the mass number. Okay. Okay. Have a try. Have a try.
13.
Yes. Okay. Proton number is 13. And then mass number,
27.
correct. Excellent. Okay. Try nitrogen, number of neutron, and number of electrons.
7.
7. Yes. Okay. Number of electrons.
7.
Yes. Okay. Calcium, proton number,
20.
20. Yes. Okay. Number of electrons.
20.
Correct. Excellent. Okay, that is great. Okay. Next, complete the electronic configuration for the following elements. Okay. Now electronic configuration is this part. Okay. Yeah, here. Okay. What we did before. Okay. Okay. So first we need to know the first shell can fit 2 electrons only. Second shell, 8 electrons. The third shell, 8 electrons. Okay. So we have the example here. Example, carbon, 6 electrons. It will be 2, 4, the electronic configuration. Okay. So this is what we need to answer. Okay. So we can go through an example together. Sodium. Okay. So sodium, we have proton number is 11, mass number 23. So in this case, we don't care about the mass number. In this case, we want to know how many electrons. Proton number is equal to the how many electrons is 11. Okay. So we know the first shell maximum is 2, second shell maximum is 8, third shell maximum is 8. Okay. So which means for sodium, it will be 2 plus 8 plus 1 equal to 11. So our electron configuration will be 2, comma 8, comma 1. So that will be our electron configuration. Okay. So this will be our answer. Okay. So maybe you can try sulfur S and potassium K. Okay. So have a try. Tell me your answer. Okay, so sometimes we get to the last number, so we can just fill in the last number. Mm. Yeah. Okay, maybe potassium we can do together because potassium is harder. Okay, potassium is 19. Okay, so number of proton equal number of electron is 19. So it's equal to 2 plus 8 plus 8 plus 1. Yeah, okay. So equal to 19. So our electron configuration will be 2881. Okay. So we just need to know the first three shell, 288. If we have extra, we just put in the fourth shell, just like that. Okay. So our answer will be 2881. Okay. Yeah. Okay. Maybe sulfur you can try. Okay. You can try it for sulfur. Okay, can get the answer for sulfur?
286.
Correct. Excellent. Yes. Okay. 286. Okay. Yeah. So we can, yeah. So basically, this will be asked in the exam. So we need to know how to work out the electronic configuration. So sometimes they just ask us to like give the answer like this 286. Okay. So sometimes they will ask us to draw it, for example. Okay. So for example, for sodium, okay, so we can just draw like this. Okay, 2, okay, 8, okay, 1, 2, 3, 4, 5, 6, 7, 8, and then 1. So the last one we can put anywhere. Okay, yeah, example. Okay, next, define the term relative atomic mass. Okay, so we know example. Okay, so as we mentioned before, a okay, yes, this. Okay, relative atomic mass. Okay, so here example carbon. Inside the carbon we have um 6 proton, okay, 6 neutron, okay, and then electron 6. Okay, so if we want to consider the mass, how heavy, okay, we only care about proton, okay, and neutron, but electron we don't care about it. Why? Because electron is about 2000 times 2000 times lighter. Okay, 2000 times lighter. Basically we just ignore it. Yeah, we just ignore it. Okay, so which means if this proton is like a watermelon, okay, the neutron will just be like watermelon because it's 1 to 1. The relative mass is 1 to 1. So the electron maybe it's just a watermelon seed. Okay, so it is much, much, much smaller. So normally we consider the mass, we just care about the proton and the neutron. Okay. So if we search on the internet, okay, a mass of a proton, oh yes, okay, so we will get this. 1.67, a lot of decimal points, multiply 10 to the power of 27, negative 27 kg. Okay. How about neutron? Okay, neutron. Okay, same thing. Okay, 1.67. Okay, so this is one proton. If we have one proton, 1.67, 10 to the power of negative 27 kg, and then neutron also 1.67, 10 to the power of negative 27 kg. Okay, so how about electron? Mass of electron. Okay, electron will be 9.11, 10 to the power of negative 31 kilogram. Okay, so we can see they are all extremely light, extremely, extremely light, very, very light. Okay, uh, 0.000000000, and then 167 kg, something like that. Okay, 27. Okay, so basically it's extremely light. Okay, so we normally don't use this, okay, because it's very troublesome, so many decimal points. We normally don't use this. We just use a relative mass. Okay, we just use the ratio. Yeah, so yeah, so basically we are using the ratio. Okay, so let's say this is a proton. Okay, uh neutron, electron. Okay, so this is the actual mass. Okay, actual and ratio. Yeah. Okay, so the actual will be 1.67 times 10 to the power of negative 27. 1.67 times 27, negative 27, 9.11, negative 31. Okay. So if we get the ratio, okay, so we will get 1 to 1 to 1 over 2000, something like that. Okay. So basically, we will look at the ratio. Okay. So the ratio is the easier way to compare it. So this way is a little bit troublesome to compare. So normally we will compare as a ratio. So that's what we mean by the relative mass. Yeah, okay. So that's the concept of relative mass. Okay. And then coming back to our atom. So when we look at the mass, we don't look at the actual mass. We just count how many proton, how many neutron. We don't count the electron for the mass. Okay. So here for the carbon, we are saying that the mass is equal to 12. Okay. Why? Because 6 proton plus 6 neutron. Yeah. Okay. So it's 12 unit of mass. Okay. We don't use the actual mass. We use the relative mass, which is 1 for proton, 1 for neutron. So if we plus together, that is 12. Okay. So basically we'll use this. We just count each element, how many proton, how many neutron. Example, hydrogen, 1 proton, the mass is just 1. Okay. Yeah. So okay. Yes. Relative atomic mass. So for any element, we just count how many proton, how many neutron. So example, the lithium, 3 proton, 4 neutron. So the total, the mass is 7. Okay. So the relative atomic mass, okay. So basically it's talking about this concept. Okay. And then we compare with 1 over 12 of the carbon. So just now we know carbon is 12, the mass, okay? But we just want 1 unit. So we divided by 12, okay? So that's the concept there, okay? Yeah. So basically our answer is like this, okay? Relative atomic mass, okay? 12 times mass, okay, of 1 carbon atom is basically is 12, okay? But the average atomic mass will be 1 over 12 of the carbon because we just want 1 unit. Okay, next, we were talking about the isotope yesterday. Yeah, we were talking about the isotope. Okay, so example, this argon. Okay, so this argon, we have 3 type of argon. The proton is the same, 18, 18, 18, but we see here 40, 38, 36. Okay, so this one, neutron. Yeah, okay. The difference is in neutron. So what we are actually talking about here, example, like this is a small apple, this is a medium apple, and this is a large apple. They are all apple. It's just different size of apple. Okay, so that's the concept here. So if we want to know, so let's say in our basket, okay, we have 2 small apple, 3 small apple, and then 5 large apple. So we want to know on average, okay? So this small apple maybe is like 50 gram, and then this medium apple is 70 gram. The large apple is 100 grams, okay? So we just want to know the average mass of 1 apple. So we will take 2 times 50 gram, okay, plus 3 times 70 grams plus 5 times 100 grams, and then we divide by, in total we have 10 apple. Okay, we divided by 10 apple. So that will give us the average mass, okay, of 1 apple. Okay, so we are calculating the average mass. So we'll take okay, 100 plus 210 plus 500 divided by 10. Okay, like this. Okay. So it just tells us on average, each apple is 81 grams. We have a 50 gram apple, 70 gram apple, 100 gram apple. But overall, on average, we have 81 gram apple, like that. Okay, so this one, we will do the same for the argon. Yeah, okay. So one example here we can see, okay. So chlorine, so we have chlorine, both chlorine, but one is chlorine 35, one is chlorine 37, okay. So we are just saying that the chlorine 35, we have 75%, okay, and then the chlorine 37, we have 25%, okay. So we calculate that, we get 35.5. So same thing, we are calculating the average, like what we are doing with the apple here. We are calculating the average, okay. So if we look at this question here, same thing, we are calculating the average, okay. Using the example of different atom of the carbon shown, explain the meaning of the term isotope in terms of number of protons and neutrons, okay. So as I mentioned just now, what it means by isotope, they are the same element, it is still carbon, but they have different mass number. Yeah, okay. But inside this mass number, the P is still the same. The difference is on the neutron. Yeah, so the neutron is the thing that is different. C12 has 6 neutron. Yes, and C14 has 8 neutron. Both have 6 protons. So they are the isotopes of the carbon. So we are just saying that they are both apples. It just one is a small apple, one is a big apple. Okay, next. Uh, okay, yes, and then we need to calculate the um, relative atomic mass, which is the average. Okay, so if we have, you see this one, the percentage we can see here. So it's just telling us that example, we have 9 small apple, we have 99 small apple, and then 1 big apple. Yeah, something like that. So we want to calculate the average mass. Okay, so yes, C13, 1.1%, C12, okay, 98.9%. Okay, so how do we do the calculation? Okay, like this. Okay, carbon 13, 1.1%, carbon 12, 98.9%. Okay, so this one divided by 100 is just we dividing the 100%. So that will give us 12.01. Yeah, okay. So the average mass is 12.01. So we have carbon 12 and then carbon 13. This is 98.9%. This is 1.1%. Okay. After we calculate the average is 12.01, which is much closer than 12, which makes sense because this is 98.9%. Yeah. Okay, so we are calculating the average. Okay. Next. Okay, so this one we also mentioned, excuse me. Okay, so this one we mentioned just now, carbon 12, carbon 13. The proton number is still the same. Okay, proton number equal to 6, electron is also equal to 6. Okay, so means both of them have the same number of electrons. Okay, so if they have the same number of electron, the electron configuration is the same. 2, 4, 2, 4. Okay, so we know that the chemical properties, it depends on the electrons. Okay, so if the electron, they are the same, means the chemical properties will be the same. Their chemical reactions will be the same. Okay, so that is the concept there. So the isotope, it just changed the neutron. That's all. Okay, the chemical properties will be the same. Okay. Atoms of the same element with the same chemical properties because they have same number of electrons and therefore same electronic configuration. Yeah, they have the same electronic configuration, so the chemical properties will be the same. Okay, next. Okay, so 2 more pages to go. Okay, so here we have metal zinc can be extracted from its ore, zinc sulfide, okay, in a two-stage process, like what we mentioned just now, like the copper. Okay, so again, zinc and then zinc sulfide. Okay, so the zinc sulfide is not that useful, it's just a rock. Okay, but the zinc metal is very useful, so we can use it as like to make a machine, to make buildings, yeah, to make lots of things, yeah, because it's a metal. Okay, so we want to take this ore, the zinc sulfide, and then turn it into the zinc metal in a two-step process. Okay, so first from the zinc sulfide we turn to zinc oxide and then finally to zinc. So this is our objective. We want the zinc. Okay, so the second part of the process involves a redox reaction. Zinc oxide react with carbon at high temperature to form zinc metal and carbon monoxide. Yeah, so this is the process. Okay, so we have oxidizing agent and reducing agent. Yeah. Okay. So now, first we try to work out. Okay. So what is the species that is um oxidized? Okay. Which one is reduced? Okay. So oxidized, yesterday we mentioned is added oxygen. Yeah. Okay. If it is added oxygen, it is oxidized. So in this case, is carbon. Carbon is the one oxidized. Okay. Which one is reduced? Reduced means remove oxygen. Yeah. Okay. So which one is remove oxygen? Zinc oxide. Yeah. So carbon, it become carbon dioxide. It added oxygen. So it's oxidized. This is oxidation reaction. Okay. Zinc oxide, it turns to zinc. Okay. It is reduced. Okay. Remove oxygen. Reduction here. Okay. So yeah, so that's okay. And then oxidizing agent and reducing agent is opposite. Okay. So you see this zinc oxide, it is reduced. Okay. So the reduced one is always the oxidizing agent. It goes opposite. Okay. The carbon is oxidized. Okay. And then it goes opposite. The oxidized one is the reducing agent. Okay, always remember it's opposite. Why? Because it reduced the zinc oxide. The zinc oxide oxidized the carbon. Okay, so if it is oxidized, it will be reducing agent. If it is reduced, it will be the oxidizing agent. Okay, okay. Come on. Okay, now, so what means? So oxidizing agent is the one that oxidize another substance and itself reduce. Yeah, okay. So that's the zinc oxide. It oxidizes the carbon from carbon to carbon dioxide, and then itself, it is being reduced. Okay. Reducing agent, it reduce another substance. Okay. So the carbon, it reduced the zinc oxide to zinc, and then itself is oxidized. Itself, it increased the oxygen. Okay. Next. Okay, which substance is the oxidizing agent? Okay, so just now we mentioned the oxidizing agent will be the zinc oxide. Okay, and the reducing agent is the carbon. Okay, yes, it goes opposite. Okay, exam style question. Okay, so here we have information of 4 different elements. Okay, so based on the, we need to complete the table. Okay, yes. So W, is this a metal? Is it shiny? So our answer will be yes, because we know metal is shiny. So conductor electricity, yes. High melting point, yes. Okay, this is our understanding. X is non-metal. Okay, shiny, no. Conductor, no. Melting point will be low. Okay, so that's our understanding of non-metal. Okay, why? We don't know, but we know it is shiny, conducting electricity, high melting point. So we know this is a metal. Okay, Z. Okay, non-metal, not shiny. So the conductivity will also be no, and melting point will be low. Okay, next. Okay, zinc is a metal. Give one property of zinc that is not shown in the table. We show that it is a metal. Okay, so let's see whether we have in the notes. Okay. Ah, yes, yes, we have it. We have it. Okay, here. Okay. So the difference between metal and non-metal. Yeah, so metal properties, solid, good malleability, good ductility, shiny, okay, high melting and boiling point, okay, high density, good conductivity. So these are the properties we can put in the answer. Okay, so example, we can say high density. Okay, next. Okay, okay. Last page on this worksheet. Okay, sparklers, they are a type of firework. They usually consist of a chemical mixture that has been molded into a thin wire. Okay, one of the main substance found in the mixture is iron powder. Okay, fireworks. Okay, the word equation for one of the main reactions it takes place during the burning of a sparkler is we have iron plus oxygen, it turns to iron oxide. Iron plus oxygen, it turns to iron oxide. Yeah, okay. Give the name of one of the reactants present in the word equation. Okay, so this part before the arrow, that will be the reactants. Yeah, okay. So our answer will be iron and oxygen. Okay, give one of the compound present. So this will be element, element. Iron is element, oxygen element. It forms a compound of iron oxide. Yes. Okay. So the compound will be the iron oxide. Okay. Write a balanced chemical equation for the reaction. Okay. So we need to balance this. Okay. So this is 1 iron, 2 oxygen. So here is, okay, 2 iron. Okay. 3 oxygen. So we need to balance it properly. Okay. So let's say we put here 2. Okay, so let's say we put here 2, it will be 4 iron and then 6 oxygen. Okay, so how can we match this up? So which means here we need to have 4 iron to get 4 iron here. Okay, and then here we need to have 3 times 2. Okay, to get 6 oxygen here. So that is our balance equation. Okay. Yes, okay, with the state symbol, iron is solid, okay, oxygen is gas, finally, iron oxide is solid. Okay, next question. Yeah, okay, final question on this paper. Okay, iron is usually extracted from the ore hematite, okay, which is iron oxide. Same thing, okay. Fe2O3 is not that useful. It's just basically a rock, okay. Iron is the metal. Iron is the one that is useful to us. Okay. So we want to take this Fe2O3 and then turn it into iron. Okay. So we have some process here. Okay. So this is the outline of the reaction. So coke is actually carbon. Carbon plus oxygen, it turns to carbon dioxide. Okay. And then the carbon dioxide react with carbon again will turn to carbon monoxide. Okay, so this carbon monoxide is the one that react with the iron, okay, to form iron plus carbon dioxide. Okay, so this is our final product. So this is what we want. Okay, the iron. So we're starting with carbon dioxide, iron oxide, it turns to iron. Okay, write a balanced chemical equations for reaction 1. Okay, so just now we already have the carbon, oxygen. Okay, so if we balance it properly, we should get this. Yeah, okay. So carbon, solid, oxygen gas, CO2 gas. Okay, so it's completely balanced. Okay, second reaction. Okay, so CO2 plus carbon, 2CO. Yeah, if we balance everything, gas, solid, gas. Okay, which substance in B oxidized in reaction 1? Okay, our answer is carbon because it increased oxygen. When it increased oxygen, it means it is a oxidation. Okay. Yes, carbon is oxidized. Okay. Which substance is reduced in reaction 2? Okay. Our answer is carbon dioxide because it reduced the number of carbon. Yeah, so that is a reduction. Okay. Next. Complete and balance the following equation for reaction 3. Some spaces might be left blank. Okay. So as we mentioned just now, okay. So we have the Fe2O3 and we have the carbon monoxide. Okay. And then we turn to iron and then finally carbon dioxide. Okay. So how do we balance this? Okay. So we know that, okay, I think we did it just now. Oh no, we did not. Okay, so let's try to balance this one. Okay, Fe2O3 plus CO turns to Fe and then CO2. Okay. Okay, so this is 2Fe. Okay. Total for oxygen 3, 1 for oxygen. Okay, 1 carbon. Okay, and then so here is 1 iron. Okay, 1 carbon. Okay, 2 oxygen. Okay, so what we can do is, okay, we can do it step by step. Okay, so first, this iron, we need to make it 2. Yeah, okay, because this is 2 iron here. Okay, so this part is done. Okay, next. So this is 4 oxygen. So here is 2 oxygen. So which means we need to put 2 here. Okay, so let's say if we put 2 here, so it will be 2 carbon, okay, 4 oxygen. Okay, so let's see. If we put 2 here, okay, so this one we must change to 2. Okay, so if we change to 2, so there will be 2 carbon here. Okay, but now we have 3 plus 2. Now we have 5 oxygen. Okay, so this is a problem. Okay, so now we need to fix it further. Now we need to make it 3. Okay, so if we make it 3 here, so it will be 3 plus 3. So it will be 6 oxygen. Okay, now what we can do here? Okay, so we need to make this 3 as well. So now this is 3 carbon. Okay, and then this is 3 carbon. Okay, so this is done. Okay, so if we have 3 carbon, so 3 times 2, 6 oxygen. Okay, now it's totally done. Okay, so our correct equation should be like this. Okay, so we just need to do it step by step. Next, in reaction 3, which substance acting as the reducing agent and which one is acting as the oxidizing agent? Okay, so if we see clearly, reducing agent is the one that is oxidized. Okay, so which one is oxidized? This one. Okay, because it goes from CO to CO2, increase oxygen. Yeah, so the CO will be the reducing agent. Okay, and then this one, it gets reduced because it decreased the oxygen. Okay, this is reduced means this is oxidizing agent. Yes. Okay, so our answer here. Okay, reducing agent is the CO because it gets oxidized. Oxidizing agent is the iron oxide because it gets reduced. Okay, yeah, so with this, we finish all the practice questions on the workbook. Okay, so coming back to here. Okay, so wait. Okay, so means this is done. Okay, so next we will move on to bio again. Yeah, okay. So we will move on to bio again. And then now, this is finish. Okay. Okay. This workbook is finished. Okay. So now we completely finished the unit 2 for chemistry. Okay. So next we will move on to the biology. Okay. Yeah. So we will be back to biology first because last time we did a big topic on the physics. So we'll be back to biology first. Okay. And then yes. So now we are on week 2. Okay, week number 2. So this is our progress on the chemistry. Okay. So now we back to biology. So we already done unit 2. So now we will get started on unit 3. Okay. So we will close this. Okay, so now we will go to bio unit 3. Yeah. So now this chemistry already completed. Moving on to biology unit 3. Okay. I think I already sent to you yesterday. So I think you have the notes already. Okay. So biology unit 3. Okay. Um okay. Okay, let's take a look. Okay. Yeah, so in this topic, we will look at movement in and out of cells. Okay, so the different process. Okay, so we know each of our cells, we have a cell membrane. Yeah, okay. So each cell, we have a cell membrane. Okay, so this cell membrane, it helps to control what is going inside the cell, what is coming out of the cell. This is very important because we don't want simply anything to come inside our cell. We want to protect ourselves. Okay, so the cell membrane will protect us. It just allow certain things to pass through to come inside the cell. Okay, so we have the cell membrane. It's got different ways to control this process going in and out. Okay, so these are the 3 different ways: active transport, diffusion, osmosis. Okay, so these are the 3 ways the cell control what is coming in and out of our cells. Okay, so the first one we look at is the diffusion. Okay, so what is a diffusion? You might remember we learned about diffusion in chemistry. Okay, so we also have diffusion in biology, is slightly different. Okay, so we focus on the diffusion in biology. Okay, so what's diffusion? is important process for living organism because it helps us to get the gas and minerals and solids that we need. Okay. It also helps us to remove some substance. Okay. So it helps us to get the things that we want and also help us to remove the things that we don't want, like something toxic, the things that we don't want. Okay. So what is diffusion? Diffusion is a movement of particles from a region of high concentration to low concentration. Yeah, okay. Because of the random movement, okay? We learn in chemistry, we have this random movement of particles, kinetic particles theory. So all the matters are made up of particles, okay? So if we don't do anything, they will just move randomly. Yeah, okay. So this is an example of diffusion. Yeah, okay. So if we have, okay, high concentration here, if we have lots of them, high concentration, after some time, it will just spread out. Yeah, so it will just spread out until it's completely spread out. Okay, so this is what we call diffusion. Yeah, okay. So if we don't do anything, it will just simply spread out by itself. Okay, so this is what we call diffusion. Okay, and then in biology, we have a few diffusion process that is very important for us. Okay, yes. Okay, um, alveoli in lungs, alveoli in lungs, and stomata in the leaf. Okay, so diffusion can happen in the alveoli for the for oxygen and carbon dioxide. Okay, so we will have a look quickly how it happened. Okay, so this is the alveoli in our lung. Okay, it's the air sacs. Okay, so these are the small air bubbles. We have thousands of them in our lung, which help us to get the gas that we need. Okay, so this is our blood vessels. Okay, so the blood, it will bring the blood vessels will bring the blood. Okay, so this one is from our body. So our body already use up the oxygen. So the oxygen will be low, the carbon dioxide will be high. Okay, so in our body, we will use up the oxygen. Oxygen will be low. We will produce the carbon dioxide. So carbon dioxide is high. Okay, so at this point here, oxygen is low, carbon dioxide is high. Okay, so which means when carbon dioxide is high, it will diffuse out. It will go out. Okay, oxygen is low, so now oxygen wants to come inside to our blood. Okay, so that is the diffusion. Okay, so once this process is done, we will come to this part. Now our blood has a high oxygen, low carbon dioxide because oxygen already come inside to the blood, oxygen already gone outside. Okay, so this is what we want. Yeah, so now our blood is in a good condition again. It got high oxygen, which is what we need, low carbon dioxide, what we don't want. Okay, so this is very important process for our body, for us to get the oxygen that we need. Okay, another one, it happened in the leaf. Yeah, okay. So for the leaf to get the oxygen. Yeah, okay. So this is the leaf, okay. And then this is the stomata, okay, the stoma. So for the photosynthesis, okay, the um the leaf, it will produce lots of oxygen. Yeah, okay. During the photosynthesis, so the oxygen will go out. And then for the photosynthesis, it need carbon dioxide. So the carbon dioxide will go in. So this is how diffusion can happen in the leaf. Okay. So here, inside the leaf, oxygen is high, carbon dioxide is low because the leaf will produce the oxygen, will use up the carbon dioxide. So high oxygen, so the oxygen will go out, low carbon dioxide, so carbon dioxide will go in. So this is how diffusion happen in the leaf. Okay, yeah. So as we mentioned before, Okay, so these gas particles, they are moving randomly. So they already have energy in them. So this is the energy for diffusion. Yeah. So for us, this is a free process. We don't need to do anything. Okay. It just naturally it will happen by itself. Okay. Because of this concentration gradient. So we have a high oxygen here, low oxygen here, concentration gradient, it will go in. Okay. And then here, high carbon dioxide, low carbon dioxide, concentration gradient, it will just happen automatically. So this is very good for us. We don't need to produce extra energy for that. So diffusion for us is a free process. Okay. Yeah. Okay. Yes. Rate of diffusion. Okay. So now, example, in our lung, we want the diffusion to be fast. Okay. Efficient. Okay. We want the diffusion to be fast so we can get oxygen faster. Okay. So example, we want to run away from the lion. Okay. Like thousands of years ago, we still primitive lifestyle. We want to run away from the lion or the tiger. So who can run faster? The person who can get oxygen faster because they can produce energy faster, they will survive from the tiger. So this is very important. If you just 1 second faster, you can survive. Okay. So this how fast we can do the diffusion is very important for our survival, especially thousands of years ago. So now we want to look at our lung. Okay. How our lung is adapted. Okay. How our lung have a very good um design so that to make the diffusion very efficient. Okay. So first, the distance. Okay. Thin wall of alveoli and capillaries. Okay. So if we come here and take a look, yeah, okay. So if we look at this, is one cell thick, okay? Only one cell thick. This one is also one cell thick, okay? So the distance is very short, okay? So it does not go like very far distance. It will take a long time, okay? So our body, all of this is very thin, very thin layer. So the oxygen can go in very fast, the carbon dioxide will come out very fast. Okay. So that's the first adaptation. Thin, moist wall. Yeah. Okay. Next. So this will help the diffusion to be faster. Concentration gradient. Yeah. Concentration gradient means we have a difference in concentration. Yeah. Example. So here we have oxygen is high. Here oxygen is low, so there is a gradient. So oxygen will come here. So here, carbon dioxide is low. Here, carbon dioxide is high. So it will go in this direction, concentration gradient. Yeah, so because there is a concentration gradient, the diffusion can happen. If both sides same concentration, there will be no diffusion, like what we saw here. You see here, if both sides same, no diffusion can happen. Only when we have a difference in concentration, it can happen. Okay, next. Okay, surface area for diffusion. Yeah, okay. So if you look at this, the alveoli in our lungs, we have like this, lots of them, lots and lots of them. So we can see it got a lot of surface area for the gas exchange to happen. Yeah, so we have thousands of them, this alveoli, a big surface for the gas exchange to happen. So that also helps with the diffusion. Okay, and temperature. Okay, so in this case, the higher the temperature, the faster the diffusion. Yeah, okay. But normally for us, the body temperature is good enough. Yeah, we don't need the too high the temperature. Okay. Yes. So that is our adaptation. So if we look at our lung, it just look like nothing special, but actually it is very special. It got all of these characteristics that make us, our breathing, our diffusion is very efficient, it's very fast. Okay, so that's why we can survive thousands and thousands of years. The human species, we haven't died off because we have this very good efficient system for us to get oxygen, and then we can get energy faster, we can run away from danger. Okay, next. Yeah, okay. So this one, okay, we will come across this. We can calculate the rate. How fast the diffusion happen? The distance traveled divided by the time. Okay, so we will have some practice later. Okay. Next. Oh yes, osmosis. Okay. So just now we mentioned we have three types of movement: diffusion. Okay. Osmosis. Okay. Active transport. Okay. Yeah. So if anytime, any question, just stop me. You want to like go to toilet, anything, you just stop me. Okay. Otherwise, we will keep going. Okay, so now we will come to the second type of movement. Okay, so yeah, so just now we talk about diffusion. We go from high concentration to low concentration. Okay, so whenever we have a difference of concentration, it will happen, the diffusion. Okay, so next, osmosis. Okay, so actually, osmosis is also diffusion, but it is a special type of diffusion. Okay, it's special. It's just talking about water. Okay, so diffusion, it can be anything. It can be gas, it can be ions. Okay, yeah, it can be molecules, it can be anything. But osmosis is just talking about water. Okay, and then it happened with the cell membrane. Okay, cell membrane. Only when we have cell membrane, the osmosis can happen. Okay, this one, diffusion, can happen with or without cell membrane. Okay, but osmosis is only with cell membrane. Okay, why we talk about osmosis? Because in biology, water is very important. So we have a special um, topic. It's just about water. Okay, so water is important to living things. Okay, it is a solvent. Okay, so many things, many process, we need water for it. Okay, we need water for it. So that's why we talk about osmosis. Okay, so we need osmosis for some important processes. Okay, like digestion. Okay, transport, excretion. All of this we need water. Okay, if we need water, means osmosis is very important. Okay, so what is osmosis? As we mentioned just now, it's a special type of diffusion. It's talking about movement of water, okay, in a partially permeable membrane. Okay, so partially permeable means only some of the things can pass through. Okay, like water can pass through. Okay, yeah. So plants, yeah. So for plants, osmosis is very important. Okay, we'll look into this later. Okay, now we'll take a look what it means by osmosis. Yeah, okay. So if we see carefully, okay, uh, what is different about osmosis? Okay, so the main thing that is different here is the membrane. Yeah, okay. Now this membrane, can you see? It's got the pores. Okay, so the pores, they are small. Okay, okay. So means water can pass through. Example. And then this one, the solute molecules. Okay. So example, maybe let's say we have protein. Okay. So protein molecule, example, or large particles. Okay. they cannot pass through because these pores are small. Okay. So the protein, the large particle cannot pass through. Only water can pass through. Okay. You see here, the red particle is high concentration. Okay. So if we do not have the membrane, the particles will come here. The red particles will come here. Okay. But the pore is too small. The red particles, they cannot pass through. They cannot pass through. So they will stay here. Okay. So what will happen? The water molecules will come. Yeah, the water molecules will come because the water molecules will can pass through the pores. Okay. So we see here what's actually happening. The water is the one that will pass through. Okay. So that is the difference between osmosis and diffusion. Osmosis, we have the membrane. Okay. We have the membrane. The red particles cannot pass through. Only the water can pass through. Okay. So in the end, we still have equilibrium. We still have both sides. It become same concentration. Yeah. Okay. So only movement of water. Yeah, only movement of water. These large particles cannot pass through. Okay. So we can see the water level is changing. So that is the concept of the osmosis. Only water can pass through. Okay. Next. Okay. Yeah. Okay. So just now we already learned about the osmosis, how it happened. So next we're going to look at how it affects the plant tissue and animal tissue. Yeah. Okay. So let's take a look. Okay, how it affects the animal tissue and plant tissue. Okay, let's take a look at plant first. Okay, so if we look at when water is a lot, okay, and then this one is when water is little. Okay, so when when water is a lot, the water will go inside the cell. Okay, so we can see the water will go inside the cell. The cell it become turgid. Okay, and then when water is very little, then the cell will go out. Yeah, the water in the cell will go out. So the cell will become plasmolyzed. Okay, so this is not good for the plant. When there is less water, the plant will be losing water and then it may die out. Okay, and then this one is when inside and outside same. Okay, when inside and outside same, both way can happen. Okay, both way can happen. So means nothing change. Okay, nothing change. Okay, so this is the effect. Okay, so if we look at the condition of the plants, okay, this turgid is good. Turgid, excuse me. The turgid is good because the plant um it can be normal. Okay, so it can be upright. Okay, but if we have this situation, the plant is just a little bit flaccid. Okay, it's not like full. The cells are not completely full. Okay, but if we have this situation, it's even worse. The plant is totally wilted. Okay, so it got totally lack of water, and then it cannot stay upright like this. This is a healthy normal plant, but this two situation is not okay. Yeah, okay. Yes. Okay, some additional points. When we place in water, like this situation, the plant and animal cell, they will take in the water by osmosis. Yeah, so water will go in. The plant cells, they will become swollen but do not burst. Okay, they will become like big, but they do not burst because they are protected by the cell wall. Yeah, okay. So the plants will be supported by the pressure of water inside pressing outward. Okay, but how about animal cells? Okay, so this is the situation. Animal cell, like red blood cell. If we have lots of water, the water will go inside. Yeah, it will get bigger and bigger and then it will burst. Okay, so it will die. Okay, so if we have inside and outside same amount of water, then it will go in and go out, no problem. Okay, so it's just normal. If we have very little water, then the water will come out of the cell. Okay, by osmosis, come out of the cell. The cell will be shriveled. It will be shrinking. So in like very serious situation, it will also die. Okay, so we can see for our body, we need very uh, we need finely control concentration. We cannot have too much water, the cell will die. Too little water, the cell will also die. We need it to be just right. Yeah, okay. And then yeah, so animal cell is not same as plant cell. Plant cell, they are protected by the cell wall. They will not burst. But animal cell, they will burst. Yeah, because they have no cell wall. Okay. Yep. If we put in like concentrated solution, like this situation, like very concentrated solution, lack of water, so the water will be going out. So they will be lack of water. So they will be um, shrinking. Okay, so that not a good situation for plant and animal. So both for plant and animal, we want just right, the amount just right. We don't want too much, we don't want too little. Okay, sample question. Okay, so we can take a look. We have some sugar solution collected from the phloem of a plant cell. So the plant cells placed on the microscope slide covered with this sugar solution. Okay, describe what changes would occur with each of the three cell parts if the sugar solution was more concentrated than the sap. Okay, so basically, we have uh, okay, so basically we have this situation. Okay, if we see here, the sugar solution more concentrated than the sap. Okay, so we have this situation. Yeah, okay. Sugar solution more concentrated means sugar is high, water is low. Yeah, so when we have high sugar, low water, we have this situation. Okay, so water is low. So means the water will be coming out from the cell. When outside is low, inside will come out. Okay, so this is our situation. So what happened here? The set vacuole will get smaller. So we can see here, the set vacuole will be smaller. The cytoplasm will be shrinking and pull away. So we can see the cytoplasm shrinking and pull away from the plants. Okay, and then what else? From the cell wall. Okay, so it's pulling away from the cell wall. Okay, and then the cell will stop stretching and stop curving outwards. So it will not be like this curving outward. It will be like this. Okay, so this is what we call plasmolyzed. Okay. Yeah. So this one is a technique we can use to study the osmosis. Okay, so we can use this tube here. This is a dialysis tube. Dialysis tube is also semi-permeable. Okay, so it's similar to our cell membrane. Similar to our cell membrane. So the water can pass through. Okay, so the water can pass through, but inside the red dye, okay. So it's like our situation just now. Okay, so let me just bring the picture. Yes, this picture here. Okay. Yes, it's similar to our situation here. Okay. So the red dye, it actually cannot pass through the membrane, cannot, but the water can pass through. Okay. So the red dye will stay inside, but water will go in. Water will go in. So in the end, we expect the water level will go up because water will go in by osmosis. Okay. So this is one experiment we can do about osmosis. Okay. Yeah, next. Okay, so this one is another experiment we can do about osmosis. Is we take the potato, we will cut this. Okay, we will cut into this uh potato cylinder. Okay, this potato cylinder we will put in water in different concentration. Yeah, okay. We'll put in the solution in different concentration. We can see sugar solution in different concentration. So at here, low concentration, this one, water is high. This one, high concentration, water is low. Yeah, okay. So at here, water is high. Okay, when water is high, the water will go inside the tube. So we expect the tube, it will get bigger. Yeah, okay. So for this situation. So for this one, because water is low, water will come out of the cylinder. So we expect the cylinder will get smaller. So this is one experiment that we can do. Okay. Next. Okay. So you see, just now we just talking about this osmosis. Simple. Okay. Simple situation. We just talk about more water or less water. If you see this yellow box, yellow box means extended. Okay. So means if you take the extended exam, not only you must understand the outside one, the inside one, you must also understand. Okay. So yeah. So now we will talk about the yellow box. Okay. Yeah. So here we will go into more detail. We will bring in the concept of water potential. So just now we just talk about more water, less water. So now we'll talk about water potential. Okay. The concept of water potential, what it means by water potential. Okay. Okay. What it means by water potential, we'll look into that. Okay. Water potential. So this one is low solute concentration. Okay. So let's say this is 5% sugar. Okay. 5% sugar. Okay. Means you got 95% water. Yeah. Okay. So this is what we call high water potential. Okay. Because we have more water. Okay. Remember that. Okay. This one, second situation. This one, let's say this one is 20% sugar. 20% sugar, 80% water. Okay. So this is what we call low water potential. Okay. Or lower water potential. Why? Because we have less water. Okay. So example, this one 95% water, this one 80% water. So this is less water, means this is lower water potential. So this is how we compare high water potential, low water potential. Okay. So normally in the solution, we focus on the sugar. Which one got more sugar? Okay. But in the osmosis, we focus on the water. Which one have more water? Okay. Example, this one got 95% of water. Okay. So yeah. Okay. Again, the plant cell, if we put in the water, so here will be high water potential because 100% of water. So, yes, okay. So if we just put inside the 100% water, so outside, so this is the symbol for the water potential. Outside, water potential is high. Inside, water potential is low. So it will go from high water potential to low water potential. Yeah, so it will be this situation. Okay, so if we have here inside and outside, same. Yeah, so when they are same, no change. Okay, so this will be no osmosis. Okay, and then this one, if we put in a high concentration solution, so this one, outside water potential is low, inside water potential is high, so water will come out. Yeah, so that's why the cell it become plasmolysed. This one it become turgid. Okay, so that is the concept here. Okay, yeah. So for the plant, as I mentioned before, it's very important to have this turgid situation. This turgid situation is very important for the plant. Okay, so it helps the plant to stay upright. Okay, yeah. Okay, so all the cells will become turgid. The plant will be upright. So the leaf will be held out to capture the sunlight. So it will help the plant to have the photosynthesis properly. Okay. Yes. So if we have this situation here, lack of water, water will be going out, plasmolysis, the plant will be wilting. Okay. The plants will be wilting and then it will die off basically. Okay. Same thing, it happened in our blood. Yeah. Okay. It happened in our blood. Okay. So if we have uh let's say we put in the water. Okay. So now outside water potential is high, 100% water. Inside the water potential is low. So water will go inside, it will burst. Okay. So this one inside and outside, okay, same. Not no osmosis happen. Okay. So the plant it just stay normal. It's good. Okay. How about if we put in 20% sugar solution? So now outside is low water potential. Inside it has more water. Okay. So water will come out. The cell will be shrinking, shrivel. So if very serious situation, it will die off in this both situation. Okay. Yeah. So this is just going into more detail. So the fluid that bathing the animal cell, our tissue fluid, it must be having the same water potential. So inside and outside must be the same. So sometimes, let's say we drink too much water or we drink too little water, it's not good for our cells. Yeah. So higher water potential, this situation, the cell will burst and die off because no cell wall. Okay. If lower water potential, okay, then it's not good. This situation is also not good. Water will be leaving, plasmolyzed, lose their function, like red blood cell, dehydrated, reduce surface area, it will stop working. Yeah, okay. So basically this is osmosis. Okay. So it's already time. So maybe we have no time to do the active transport. So tomorrow we will do this active transport, finish the notes, and then we will look at the workbook. Yeah, for this unit 3. Okay. So the time is perfect. We will stop here. Yeah, okay. So tomorrow we will continue. So our progress is here. Okay. If no other question, we will stop here. Okay. Thank you. Bye bye. Thank you. Thank you.